Hello everyone. Today we are going to discuss about how to find out the centroid of an irregular shape. Let us solve the problem. Determine the centroid of the shaded area shown in the figure. Here you can see an irregular shape in which we have to calculate the centroid of the shaded area. While we are asked to find out the centroid of any area, first, we have to draw two mutually perpendicular axes x and y that encloses the irregular geometry. So next we have to look into whether the given irregular shape is symmetrical above any one of its centroidal axes. The symmetry about an axis means that if you fold the shape along that axis, both sides will perfectly match or coincide with each other. For our case, if you fold the given geometry about that YY axis, then the both sides will perfectly match with each other. That is why we say the given geometry is symmetrical about YY axis. So if you are able to find out that, then we can easily find out the centroid of the shape. The center of this irregular shape is located at a distance of 30 mm from this origin O, Y axis. So in this problem, the x bar value is directly determined without doing any calculations. Now we are going to calculate the centroid about OX axis, that is the y bar value of the given geometry. Let us see how to find out that. So we are going to divide the irregular shape into number of basic primitives. So let us see what are those. The first thing is we are going to consider this element as number 1 because it represents a triangle. And then we're going to consider this entire square and it is named as 2. And the third one is this part which represents a right angle triangle, which is third one. And then a semicircular area has to be removed from the entire area. So the concept of finding centroid here is, as we couldn't find out the centroid of the irregular shape directly, we're going to find out the centroid of individual basic primitives, and by using that we are going to calculate the centroid of the whole irregular shape. We are going to consider only the first element, that is the triangle. So we have drawn that reference axis OX and OY, and then we are going to consider the triangle alone in this reference axis. Okay, so this is the element number 1. The area of that element 1 is, since it is a triangle, the area of the triangle is of BH. So the height is 30 mm. So here the height is 30 mm and this breadth value is exactly 15 mm. Because the overall length is 30 mm, we have to subtract this 15 mm, which represents the radius of the semicircle, from this entire length. So 30 minus 15, so this breadth value is 15 mm. Okay, so the area is of BH, so of breadth value multiplied by the height value, which is 225 millimeter square. And then we are going to find out the centroidal distance of this element alone from the reference OX axis. So for a triangle, h by 3 gives the centroidal distance of a triangle from the reference axis. We have to be very careful about this formula. This h by 3 represents only if the centroidal distance is calculated from the base. If it is calculated from this point, that is this vertex, then the value will be h minus h by 3. Okay. So here the geometry is oriented from the base. So straight away we can take that value as h by 3. So h is 30. So 30 divided by 3, which is 10 mm. So the centroidal distance of this triangle from the reference axis OX is 10 mm. Okay. And then we have to multiply this area with the centroidal distance. So we're getting that value as 2250 millimeter power 3. So the next standard element is 2, which is the square. So this square, so which also encloses the semicircle. So it is the entire area, this one. Okay. So now let us draw the reference line again, OX and OY. So this square is located here. So the size of the square is, let's see, it is, this height is 30 mm. So we are going to consider this as 30 mm. And this length is exactly 30 mm because it encloses the semicircle. So radius of the semicircle is 15 mm. So here on this side 15 mm, on this side 15 mm. So totally here also it measures 30 mm. So how to find out the area of this square? It is size multiplied by size. So it is going to be 30 multiplied by 30, it is 900 millimeter square. And the centroidal distance of this square is easily calculated because it is going to be exactly half the distance of this size from the OX axis. So it is going to be h by 2 because this size is height, so it is going to be h by 2. So the centroidal distance of this rectangle is 30 divided by 2, which is 15 mm. Then we can multiply this area with this centroidal distance. So we'll be getting that value of 13,500 millimeter power 3. So next we are going to find out the area and centroidal distance of this triangle, which we represented as number 3. So we are going to construct the reference axes here again, OX and OY, and we are going to draw the triangle here in this orientation, same as that of how it is represented in the entire irregular shape. So this is the triangle here. So the height of the triangle is, again, it is going to be 30 mm, and the breadth is, it is 30 minus 15, that is the radius of this semicircle, so it is going to be 15 mm. So what is the area of the triangle? It is half BH. So it is half BH, which is half multiplied by 15 multiplied by 30, and we got the value of this area is 225 millimeter square. And then we are going to find out the centroidal distance about this centroidal axis. So here also we are going to use the same formula to calculate the centroidal axis from the OX, and it is h by 3. So we have to remember that always while we calculate the centroid of any triangle, if you measure the distance from the base, then it is going to be h by 3. If you measure the distance from this vertex, then it is going to be h minus h by 3. Okay. So here we measure the distance from the base. So it is going to be h by 3, that is 30 divided by 3, which is equal to 10 mm. So then we are going to multiply these two things, that is area and centroidal distance. So we get the value of 2250 millimeter power 3. So now we are going to consider the element number 4, which represents the semicircle. This area has to be subtracted from the entire region because we are going to calculate the centroid of the shaded area alone. So that is why we put minus sign here to represent this area, and this AY must be subtracted from the summation of the other three elements. Fine. So first, the area of the semicircle. Okay. So let us consider the reference axes is OX and OY, and consider this semicircle here, and this is the semicircle, and the radius is 15 mm. So first let us calculate the area of the semicircle, which is pi r square divided by 2. Because for circle the value is pi r square. Since it is a semicircle, pi r square divided by 2. So we got the value of minus 353.4. This represents the area of this semicircle. The minus sign indicates this value has to be subtracted from the rest of the areas. Fine. And then how to find out the centroid from this OX axis? So this is the centroidal axis. So this value is calculated by using the formula 4r divided by 3 pi. So here also we have to be very careful about that. So this centroidal distance represents the distance of centroid from the base of the semicircle. So if you want to measure it from this region, that is from this curved region, the value will be r minus 4r divided by 3 pi. So since we have to find out this value from this base line, it is 4r divided by 3 pi. So this value is 4 multiplied by 15 divided by 3 pi. So we got the value of 6.37, which is the centroid of this semicircle from the reference axis OX. Now we are going to multiply these two things. So we got the value minus 2251.16. Now we have calculated the area and centroidal distance of all those four elements. So first let us calculate the sigma A, that is the entire area, which is 996.6 millimeter per square. So that means we have added these three values and subtracted this one from the rest of the values. Similarly, we are going to calculate the sigma AY here, and which is 15,748.84 millimeter power cube. So here also we have subtracted this value from the rest of the values. Now we are going to calculate the y bar value. How to find out that? We have already calculated the value of sigma A and sigma AY. So y bar value is sigma AY over sigma A. Sigma AY value is 15,748.84 over 996.6. So the y bar value is 15.8 mm. So how to represent that value in this diagram? Because the y bar value is the distance between this centroidal axis, that is XX, from the reference axis OX. So this is the y bar distance what we have calculated, and it measures 15.8 mm. The x bar value we have already calculated because the given element is symmetrical about this YY axis. So x bar value we have already calculated as 30 mm. So x bar is 30 mm, y bar is 15.8 mm. And here is the centroid, which is 30, 15.8 mm. I hope you have understood this problem very clearly. Thank you for watching my lecture.